Welcome to lesson 6.4, log properties. So I've actually already filled them in for you at the top here so that we don't have any chance of somebody recording them wrong. But if you are taking notes on something that is not this piece of paper because you weren't able to print it or you didn't stop by for yours yet, this part right here is going to be pretty important. This table is probably the most important thing on these notes. So if you need to, take a second to pause and write it down. Basically, we've got three log properties: product, power, and quotient. I do not need you to know the name of the properties. All I need you to know is how they work together. So, for example, we have this product. Product means multiplication. And if you have two things that are being multiplied together, this is sort of like saying, let's see, x to the third times x to the fourth. What do you do with those exponents if you are multiplying? You add them. So this will be the same thing as x to the 7th. So what do you do if you have two things that are being multiplied inside a logarithm? Well, the log is the exponents, so you can separate it as two logs being added because you would have added those exponents together. That's where the log properties come from. These are pretty much the same thing as exponent rules, but in log form. And this works both ways. So you have something being multiplied, you can split it up using addition. That's called expanding because you're splitting it out, splitting it up. If you have two things that are already being added together like this, you can also combine those into one and make it multiplication. So that's called condensing because you're taking two and mushing it together to be one, basically. Then there's the power rule. If you had something like x to the third power to the fourth power, you would multiply those exponents together. So what ends up happening, and this one can be a little tricky because it looks kind of like this one, if you have something to a power inside of a logarithm, that power can just go out front. Or if you have a number in front of a log, you can make it a power of the thing on the inside. When you put it out front, that's called expanding. When you put it inside, everything fits inside this one logarithm. That's called condensing. Just be careful because this one also involves multiplication, but involves multiplication outside of the logarithm, while this one involved multiplication inside the logarithm. And then you have the quotient rule. The quotient rule for exponents is something like x to the fifth over x squared. You would subtract those exponents, and it would become x to the third. So, if you see two things being divided inside a logarithm, you subtract their exponents. One thing that happens with these two is anything that's negative, that's like it has a negative power out front, so it goes to the bottom. Anything from the denominator has to have a negative in front of the logarithm. If nothing has a negative, then you don't have to put either of them in a denominator and they just get multiplied. Multiplication is sort of like our default. We only switch to division if it's negative because negative exponents make it go to the bottom. Or if you have two things being subtracted, you can make it into one logarithm by dividing those two things. You just need to be comfortable recognizing which rule is which as we work through our examples. Again, expanding means you only want one number or one variable inside the logarithm. See how this is just b and this is just c? This turns into just b, this turns into just b and just c. So you only want one thing left inside. Okay? So one thing inside. Condensing means you want to put everything together so that it fits inside of one logarithm. So either there's one thing in each logarithm or it all becomes one logarithm. Okay, and it kind of makes sense that expanding, you're making it longer, condensing, you're making it shorter. And then the last thing that I'm going to say before we move down to the bottom section is there is what's called the inverse property of logarithms. Logarithms and exponents are inverses. That's the whole idea behind them. They cancel each other out, like this. If you have the log, let's say base a of a to a power, then those two a's cancel each other out and your answer is just b. Or if you have a as the base of an exponent and there's a log inside of that exponent, then this base and this base cancel each other out. Basically, if you have a log and an exponential and they have the same base, either like this or like this, those cancel, and whatever the exponent here or the regular inside part here is, that's all that you have left. Okay, that's how they cancel each other out. And I'll show you what that looks like in some real examples down here in just a second. So let's talk simplifying. And this just says simplify, it doesn't say expand or condense yet. We are going to be using the log properties, but when I say simplify, it's usually going to mean that you're going to get a value. So for example, on this one, I'm going to take log base 6 of 12 plus log base 6 of 18. Since these are being added, we can multiply 12 times 18. And 12 times 18, if you do it in a calculator, is 216. And guess what? 6 to a power does equal 216. Before I write that out, I'm going to remind you, all this is saying log base 6 of 216. I know it looks super funky and new, but it's basically just saying that your answer to this problem is the power of 6 that gives you 216, which happens to be 3. On part B, you'll notice that they're being subtracted. That means when I combine them together, I'm going to divide 1,625 by 13. And 1,625 divided by 13 is 125. Again, if you're not sure about that, grab a calculator, do some division. And now we're looking for what power of 5 equals 125, which happens to also be 3. Okay, so the whole idea here is that we're using these log properties. Look for a way that you can simplify what you're looking at. On part C, this is the one that typically freaks people out a little bit because there is a log with an exponent. That exponent can just go out here. And then it's not there anymore. So now I can do 5 times whatever log base 2 of 16 is. And this is a much easier problem to work on because we're just looking for the power of 2 that gets us to 16, which happens to be the 4th power. And 5 times 4 is 20. Boom. Same thing on part D. Don't stress out when you see this. Take the exponent, put it out front first. In fact, if you ever see an exponent in a logarithm, throw it out front because that's going to make the problem way easier for your brain to process. Then you have log base 3 of 3. 3 to what power is 3, guys? 1. So you basically have 11 times 1, or 11. And I am showing every little tiny bit of my work so that you guys can follow along. Some of these steps would be okay to not show on yours. Now on to part E. 5 to the power of log base 5 of 10. That is an exponent on the base of 5 and a log with a base of 5. So those 5s cancel. Oops, crossed that out a little too far. Got a little too excited. And it's just 10. Done, guys. Just done. Over here, you've got a 7 as the base and a 7 as the base. Those cancel. That's the whole point. See how they were slightly different forms? They still cancel. And it's just x minus 3 left. So a little bit weirder of a problem, but same idea, same difficulty. The thing about these is they look super difficult, but they're really not that bad. And then I'm going to show you guys two ways to do part G. The first way is I need a power of 4 to exchange for my 16 because I want them to be the same like these. And I know that 4 squared is 16. So what I'm going to do is replace 16 with 4 squared. And then my 4's cancel out, and I have 2 times x minus 1. I have to distribute that. So 2 times x is 2x. 2 times negative 1 is negative 2. Done. Here's a second way of doing it. This way kind of helps people who are freaking out a little bit. This power can just go out front. I know it's a little strange, you have to put it in parentheses, but you can put the x minus 1 in front and then leave the log base 4 of 16. And then, what power of 4 gives you 16? 2. So you get a 2 times that x minus 1, and that's 2x minus 2. Okay, not everybody is going to realize that you can do this way. This way is perfectly fine too. Anytime you see an exponent inside of a log, you can just put it out front. That's exactly what we did up here. And I'm actually going to use only that method on h. You are welcome to use this one too. I'm going to throw that x to the x plus 3 out front. And then I'm looking, what power of 3 is 27? 3. 3 cubed is 27. So that leaves me with 3 times x plus 3. I'm going to draw an arrow coming down so you guys know this is 3. That's where that 3 is coming from. And that gives me 3x plus 9. And la-da-da, we're done with 8 problems already. Now, let's talk about how to expand and condense. Expand means that you can only have one number / letter in each log. So I'm going to have to separate 5x squared and y to the 5th. 3 separate things, and these are all being multiplied. Even though we can't see the multiplication dots, they are all being multiplied. So when we are multiplying them, that comes from a problem that was originally added together, because it's adding separate logs that causes them to be multiplied as 1. So I'm going to add log base 3 of 5 plus log base 3 of x squared plus log base 3 of y to the 5th. So I'm just separating them all out. That's what it means to expand. Now, I said you can only have one number or letter. These have a letter and a number because they've still got a power. You need to take that power and write it out front. You only want one thing inside of each log, 5, x, and y. So don't forget, afterwards you need to take your powers and put them back out front, just like we did up here. Okay, and then we have this one over here, which has got a fraction. Now, here's the tricky part about this one. First of all, it's a fraction. Second of all, you have to separate the 8, the x, the y squared, and the z to the 4th. So go ahead and circle all 4 of those for me. Okay, so the 8 and the x are both on top, so they are both going to get added. Because they're being multiplied. The other two are both being divided, that's why they're both in the denominator. So I'm going to subtract the log of y. And then instead of giving it a power of 2, I'm just automatically going to take that 2 and put it out front. And then I'm going to subtract the log of 7, z. And instead of putting z to the 4th, I'm going to put a 4 in front. That's my favorite one because it ends in logs. And that's your answer, guys, to both of these. As you finish up an expanding problem, make sure there is one thing in each log. It can either be a number or a letter. When you are condensing, then you should only have one logarithm left. Okay, everything's got to go inside. So opposite rules of what we did this, you just go in the opposite direction. So if anything's being added, you multiply it like this. If anything's being subtracted, it goes in the denominator. Before I move pieces, I'm going to go ahead and take my powers and put them back as exponents instead of out front. So when you're expanding, you take the powers and put them out front. When you're condensing, you want everything to go inside, so you take those powers and put them back on the inside. There are reasons why both of these are necessary. Sometimes it helps to have it written out like this, and sometimes it helps to put it together. There are different ways each problem works based off of the numbers it has. And then I'm going to make this one log, and anything that is positive goes on the top. So x and z to the 5th both go on the top. The y to the 3rd is being subtracted, so it has to go on the bottom. And since we have a fraction now, it's probably a good idea to put it in parentheses like this. And it's done. Everything is neatly tucked inside of one log. I like these better because they look neater. However, sometimes these are easier to understand because you can do it one piece at a time. This one looks a little more complicated because everything's all in one. Okay, and then this last one, there's only 2 different logs, so we are going to divide because they're being subtracted. So keep your log base 5. Don't forget to keep the same base as it started with. And then 7 goes on top because it's the positive one. 3x minus 2 goes on the bottom because it was being subtracted. Done. And I'm going to say one last thing before I kind of close out of notes. You can't change the base of the log. This one kept base 6 the whole time. If these aren't the same number, you can't do this rule. If these aren't the same number, you can't do this rule. It should be the same number on all the problems. I'm not going to make it tricky like that. Okay? I kept this log base 3 on all 3 of these. I kept this regular log on all 4 of these. Don't change the base of the log. Leave it the same. Don't make it a harder problem than it has to be by trying to add extra stuff.